Angle review activity, memory lane number 3, counts as a quiz for 4th quarter. This will be a review of angles, such as properties, types of angles, and we listed such as complementary, supplementary, vertical, etc., along with how those angles will be used in quadrilaterals, Unit 7. So this video will complement the memory lane activity. Now, this video will feature problems that will be similar to the problems that are featured on the memory lane activity. So please use this video and the notes to help you complete the memory lane number 3 angle review activity. So naming an angle, names of this angle. So angle is basically two rays that have a common endpoint. So for instance, angle XYZ. You can name this angle as angle X, Y, Z, because you start at the X, go down to Y, and then you make the turn at Y, go to Z. You could also name it Z, Y, X. Again, start at Z, Z goes to Y, and then Y goes to X. Now, third example, this could just be named angle Y because it starts at Y, and it could stop before it gets X, or it could stop before it gets to Z. But notice how all three cases, the 3-letter names, middle letter is the Y, and then the single letter, it's also Y. Now in this case, if it's a single letter, then it's the first, middle, and last letter. So that's how we name an angle. Now, you may have this parallelogram, and I may tell you, determine the angle measure of such and such angle. But we need to identify the angles. So for here, highlighter might be important. So let's say, for instance, we highlight this angle here. So we start from A, go to B, and then we go from B all the way down to D. So this angle highlighted in blue, this will be nicknamed angle A, B, D. So I'm going to highlight that angle in blue. Oops, let me write the letters a little bit more legible. So ABD, that's the angle that is highlighted in blue. So we will, and then, but notice, now you could also start from D, go to B, and end at A. So you could also say angle D, B, A. Again, the middle letter is always your turning letter. Okay, another example. So after I highlight these two angle names in blue, so I want you to see what the highlights, how they're related to each other. Now let's say if we had another angle. Let's say, I'm going to highlight this one in green. Actually, we're going to go from A to D, and then from D all the way to C. Now again, I apologize. All right, that's probably a little better. So in green, I've highlighted, we started at A, went down to D, and then we ended up at C. Now, you could have also said angle C, D, A. and I'm going to highlight that one in green. Because again, they represent the same angle because, again, D is your turning point, that's the middle letter. And you went from A to C, but you turned to D. Similarly, you went from C to D, C to D, turned to D, went up to A. Now I'm going to show you one other one. What if we had this angle here? So we start from B, go down to E, and from E down to C. So the yellow, I'm going to highlight it as B, E, C. Or we can go CEB. They mean the same angle. Because again, first letter tells us where to start. Second letter tells us where we turn. And then the last letter tells us our final destination. So we've highlighted BEC, CEB because they represent the same angle. Now, complementary angles. So the two add up to 90 degrees, aka right angle. And as you see, angle AOB, 90 degree, it's a right angle. But notice how WX to Z and ZX to Y. That also, WXY forms the right angle. That's your 90 degrees. It's the sum of WXZ and ZXY. So let me get rid of this 90 degree. But we just have to know, since we have our right angle, which I'm going to want everybody to see, WXY is just like AOB. The right angle, 90 degrees. But we know that from WX to Z was 52. So we need to figure out how many more degrees, so 52 plus something, must add up to 90. Well, this is 90. This angle right here has to be 90 minus 52. And if anytime you have a right angle, here's your right angle on the end, which will always be 90 degrees. But if you're given one angle, then subtract that one angle from 90, you get the other. So in this case, 90 minus 52 is 38. So ZXY would be 38 degrees. Again, complementary, grand total of the two angles must be 90. If you have the angle of the first one, you should be able to get the second. Supplementary angles, a pair of angles whose sum is 180. Now you have your straight line right here. Straight line we just talked about recently in class. Grand total of 180 degrees. Well, here you have a straight line, R, S to T. However, see that from S to U, there's a ray that split one part of the RST line to 48 degrees. Then this other one has to be, we know that the grand total of the two must add up to 180. So we need to figure out one number plus 48 equals 180. And basically the way to do this, just subtract 180 minus 48 is 132. So that's a quick way to check. 180 minus 48. And you'll get the same answer. Now, vertical angles are angles that are across from each other at an intersection. And they're going to be congruent. So that's why we have this example, AEB, or angle 1. Now note that angle 1 is going to be congruent to What's right across from angle 1? Angle 3. So angle 1, AEB, is congruent to angle DEC, or angle 3. Similar can be said for AED, represented by the number 2. BEC, represented by the number 4. These two angles are vertical angles, so they're across from each other. They're going to be congruent. And that's going to help you with this problem here. So basically, your congruent angles are going to be directly across from each other. So this might be an idea. Highlight one angle, go directly across, highlight it with the same color, and then you flip-flop. But then you all know, too, that you have a linear pair going across, going consecutive next to each other. So that might be another little tidbit. So you could say green plus blue equals 180. Okay. Rectangles. 4 right angles. 1, 2, 3, 4, which means they're 90 degrees. Diagonals are congruent. So basically, your diagonal B to D, so that entire line is congruent to AC. So B, D, congruent, A, C. And then they bisect each other, so basically those two sides are going to be congruent. And you could say these two sides are also going to be congruent, but in the end, all 4 of these segments are congruent. And then they bisect each other, of course, so A to E, E to C, they're the same. So that's an idea. They bisect each other. Those two measures will be equal. And the diagonals are not perpendicular. That means your angles here, 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 or there are not going to be right angles. The vertical angles are still congruent, but they're not all 90 degrees. And diagonals do not act like mirrors. So I know like the rhombus is a different story, but here, for instance, when we do our angle measurements, alternate interiors are congruent. So BCA is 18, therefore DAC will also be 18. Similarly said, BDC 72, therefore DBA also be 72. And I guess what, you probably have enough information to get all your information, because we know that the sum from this entire angle from here to here is 90. So we have 18, therefore this part right here will be 72, because 72 plus 18 is 90. And you can say something similar over here as well. 18 plus 72 is 90. Now for the other part of the problem, well, this angle ABD is 72, then DBC must be 18, because 72 plus 18 has to be 90. And same thing here. BDC is 72, BDA must be 18. So therefore we have all our angles, and the alternate interiors are in effect, because even over here And then the other rule was, since you have diagonals which are congruent, at the midpoint, these smaller segments are congruent as well. But then notice how your each segment part of the diagonal, they're also congruent. So that means their opposite base angles are also congruent. So if this angle was 72, that's why we have this angle is 72. They're not, it's not going to be 18, 18. Or here 72, 72. No. And then, of course, this rule, let's say if you need to figure out the measurement of BEC, well, add your two numbers. Once you get those, subtract from 180. So add, then 180 minus 18 plus 18. Well, minus 18 minus another 18. All right. Rhombus. Outer sides are congruent. So JK, JM, ML, LK, all four of those sides are going to be congruent to each other. Now, diagonals bisect each other. They form. And the diagonals from right angles. So that means they dissect at the outer angle. So basically at JMK, KML, these two are going to be the same. So I'm going to color code. And you could also say these two angles are going to be the same up here. Then let's see if we had another. Not the best drawing, but let's say you had another angle measure here. You have a right angle here, here, here. Yeah. So bisect each other, form right angles, and they also, but now remember the diagonals are not congruent. So that is something to worry about. So even though M to the center, and then the center to K is the same, J to the center be a little different than from the center to L. And again, your diagonals act like mirrors. There's a mirror in the K, and then J to L. That's also going to be a mirror. And we can do an example here. Since we have rhombus, four sides are congruent. Diagonals will also be bisected, so they're two smaller segments. They'll be bisected, split right down the middle. And then also, so again, diagonals will act like mirrors. So basically, even though it looks like we don't have much information, you have more than enough to get all the other angles. Now, first things first, right angle, the center point in. Oops. And then from there, I'm going to make those a little neater. And basically, since your diagonals act like mirrors, you're just reflecting all your values from one side to the other. Now, the other part is, don't forget, you still have alternate interior angles too. So for instance, if MJL is 58, then JLK is also 58, and that's alternate interior. Similarly, alternate interior, 32 over here. Alternate interior, so down here. Down here would also be 32. So plus now we know we have a 90. And then think about again, just like mirrors. So these two sides are 90. 90. 90. And if this side's 58, so is this side. And then since we have alternate interiors, 58 here, 58 down here. And then this diagonal to 32, right on the other side, 32 and 30 and 32. So you can use this diagram to help you find the angle bisectors with the rhombus. Now, square is somewhat the rhombus, the only exception. If you have a split so here, with your square, yeah, these are still right angles. And then here, if you're at an edge, that's a 90. Wow, if you're just going through a corner, and that's 45. And that's the case for all. So two numbers are going to be 90, 45. And again, everything else still the same. But now in the square, yep, just like the rectangle. All the other sides are congruent. But unlike the rectangle, here your diagonals meet, form four right angles. Last but not least, so again, consecutive interiors in the isosceles trapezoid. Yeah, so for the consecutive interiors, it's non-base. Now the base angles are congruent. So for instance, angle T is 114. Since it's on the same base as angle R has to be 114. And then the opposite angles, that should be supplementary. So rather than congruent, it's supplement. So for both cases, T and P, they're opposites. The sum must be 180. So 114 plus something equals 180. And that something has to be 66. And then this angle 66 going down, total's 180. Going across, it's 180. And then the last but not least, this base angle P is 66. Angle A also has to be 66 because they're both base angles.